So thank you everyone for coming. And I'm going to tell you again why Newspeak is double plus good. I think a fair amount of you may have heard some of this before. This is a different presentation. It's actually more introductory than the one I gave in California in a way. I don't know if hopefully those who have seen it before, repetition helps, and maybe you'll learn something new, and if not, hopefully you'll be polite enough not to say how bored you are. Anyway, so why is Newspeak double plus good? And maybe we should start with what Newspeak is. So this is a family tree. Newspeak is a programming language that is Smalltalk-like, but it is definitely not Smalltalk. Smalltalk is by far the biggest influence on it. But there are other important influences like self, which some of you may know. At least one person here knows self, I'm pretty sure. And another major influence is beta, which I suspect many of you don't know, but that is a language developed by the folks who invented the term object-oriented programming, the Scandinavians who started with Simula and then came up with something new called beta, a very beautiful language in its own right, which had the notion of nested classes. And those of you who may have been exposed to nested classes in Java, please erase that trauma from your mind. Literally, the Java nested classes were influenced by beta by a complete and total and fundamental misunderstanding of beta. And we'll get to that. So in Newspeak, I think we do it right. There's a language called E, which is a significant, if smaller, influence than those two. We'll talk about security and what E did for us in a way. And there's a slight bit of Scala influence, which you really can't tell unless you know where to look and why and what the history is. But it's a very slight influence, but credit where credit is due. So this is kind of all these things that have combined into a language and a system, again, in the Smalltalk tradition, that ends up being significantly different from Smalltalk, but still perhaps hopefully of interest to you guys. So here's a buzzword-oriented definition. Newspeak is dynamic, you know what that is. It's message-oriented, which I suspect most of you know or have kind of heard the term before, but we'll go into more details of that. It's class-based, I'm sure everyone understands what that means. It's an object capability language, which I suspect many people may not be aware of the terminology. Basically, the Newspeak design, there are two really fundamental ideas here, which sort of, once you do those, the language designs itself more or less. All the names are late bound and there's no global namespace. And we'll explain what the implications of these two things, which are pretty fundamental, as we go along. So message oriented. You may have heard Alan Kay use that phrase. When we built Newspeak, I did not know that Alan had said that Smalltalk should have been message-oriented rather than object-oriented, but I was very, very gratified to hear that later, obviously. And that really, is another way of saying all names are late bound. That basically means that essentially everything you do is a message sent, right? And sadly, Smalltalk is not message-oriented, and you can ask Alan if you don't believe me. But now, anything I say about Smalltalk should not be read as any sort of criticism. I am Smalltalk's greatest fan, as Dan knows, and I think it's wonderful. And as a programming language designer, I have looked at many, many details which you might take for granted, and you can realize that, oh, it could have gone a different way, and how subtle that is, and how easy it is to screw up. So don't take anything. I have nothing bad to say about Smalltalk, but things are different for a reason, and there are advantages I think, to some of the things we're doing. So if you think that Smalltalk is message-oriented, have a look here at this. Is this big enough, by the way, for everyone? I'm going to say yes until someone says no.
Yes, absolutely.
So if you look at this, T is assigned array new : n, right? Only the underlined part is a message sent, right? Everything in red is not a message sent. T is a variable reference of some sort, either an instance variable or a local. Let's say it's an instance variable. That's not a message. Assignment is not a message. Array is a global variable, and that's not a message. And even in the message send, n, which again could be is a variable reference of some sort, is not a message, right? And so let's suppose that we really decided, yeah, but we can use messages. We obviously have messages in Smalltalk. Let's try and make that because of the advantages of message. Essentially, message sends are good because they decouple things, right? And we're not tied to specific implementation details. So you end up with something perhaps like this, which is rather, all those selves in red are rather annoying, and there are a lot of them, and it gets rather verbose. It's not clear that this is workable, in terms of the overhead. And then there's a question for this to work, apart from writing the expression in this verbose form, of course, you're going to have to write the accessor method says if t was an instance variable, you have to write a setter for t and a getter for t, and the same for n. And what if n is a local, and all kinds of things like that. And what about array? Where did that come from? Okay, maybe I'll put a method in object so I can get at these important global things and so forth. It gets rather tedious to do this by hand. And then there's the question of, okay, now I've made everything. Let's suppose I've gone and gotten all these methods. Well, methods are public. Before, these things were say instance variables or temporaries, right? They were encapsulated somewhere, either in the object or in the context. And now suddenly I've sort of made them accessible to everyone, which is kind of at the very least bad software engineering and also terrible security and so forth. So clearly Smalltalk is not really message oriented and doesn't really facilitate being totally message oriented if you really try to do that consistently across the board. So what would one do? Well, there's this idea of implicit receivers that someone had many years ago. And basically, if you don't have to write the selves everywhere, things get a lot more reasonable. At least they look more reasonable. And so that's the first thing you might do. And that is, we got that from self, of course, which is named self, I believe, because of that. Dave, yeah.
I have to say that if you have the explicit self and you're message oriented, you really need an infinite number of explicit selves. Because where does self come from, right? It's a message to self.
I'm aware of
great
that.
retelling. Yeah.
I am aware of that, but yeah, that's a rat hole I didn't want to go down because I had this feeling I might never come out. Yes, definitely. Yeah. So one thing about this is still that these parens are slightly annoying. So we also introduced this idea of setter sends, which is just a double colon, and then it has the precedence similar to an assignment, which makes things a little bit nicer. And I'm telling you this early now, mainly because when we start to get looking at code and examples, I don't want these little syntactic details to confuse anyone. Now, the other point I'm going to make that is in Newspeak is that the implicit receiver isn't necessarily self. That's because of class nesting, as we'll see. Or in fact, if you thought of n as a temporary, what would be the implicit receiver here? Presumably the context. If you set the context up to answer messages for its temporaries. But more than that, in Newspeak, because of nested classes, it isn't always self, but it's always something that you sort of expect, something that is, you can think of it as being in scope. So the conclusion is we don't actually have variable references because all these places like T and N, right? They're now message sends. So you never actually refer to a variable directly. You're always accessing it through an accessor. And there's no assignment operator. And getters and setters are defined automatically, right? So that's kind of there's a bit more to this, but that's the basic idea. So you'll see that things look a little different. At which point, before we go into more details, I figured I'd give you a quick demo so you don't get too bored. And so this is a web page that anyone who wants to can get to. It's you can see the URL right here. Oops, I didn't want to do that. And what this does is it runs Newspeak in the browser. So this is the Newspeak IDE, and we can just check it out. So we have workspaces. We can write things. Oops. Right, and we can evaluate them. And the thing to notice is, so this is fairly obvious, but what might not be obvious to everyone, this is a link, right? The result is a link, and I can now get an inspector on 35. That's what self is. It's of class small integer. And I can do things like, right, and it does what you would expect, and I can follow that link, and I can go back. So there's a navigation model here that is different from the classic Smalltalk UI that basically Dan and company invented in the 70s, right? And it's more like a web browser, as you'd expect, or if you look at apps on mobile phones, they also follow a similar navigation model. And the fact is, the earlier version of this, or the original version of Newspeak that ran on top of Squeak, used the same UI that Vasily Bykov designed for us, pretty much on a navigation-like model like this. It isn't here because we're running in the web browser now. It's here because it worked better for us, again, because of nested classes in particular. The original class browser design really wasn't designed around an idea like nested classes, which don't exist in Smalltalk. And once you have nested classes, it just got really out of hand very quickly. So we had to have a different way of browsing these things, as you'll see. What else can I sort of demo here that's kind of interesting without getting into actual looking at code yet? Let's do this. So this is just to show you that I can get at JavaScript stuff. Oh, that's interesting. Oh, yes, that's true. This is what I wanted to write. But this is a good, here I can show you we have a debugger. So that was on purpose. This thing, right, this doesn't look like Smalltalk or Newspeak or anything. This is JavaScript. This is a JavaScript object. And we can look, it's the constructor for object in JavaScript, and it has all these wonderful properties that the JavaScript system has. The point being that I can inspect JavaScript objects, right? Now, another thing that I might mention here is, so I've been evaluating things by some keyboard sequence, but how would you know that, right? You could certainly evaluate by evaluating the selection, right? That there's a button here that's discoverable. But how would you know what the keyboard shortcut is? Well, there's a help here, this question mark. And when you open it, you get a text that will explain all these things. And it's also true that the buttons in the text, which it has text explaining this button does that, this button does something else. And if you actually click on it, then it evaluated, right? So these buttons are live, and this one clears out the result list. So if you do it here, you do that. If you get the result here again, and I click here, that does that. So we have live buttons, essentially Newspeak widgets embedded in the HTML, which is itself embedded in the Newspeak widget that is showing us the whole thing. So the reason this works is because I'm in the browser and I have access to HTML. As you'll see, the source for this help is HTML. And how would I find that? So there's a feature I've always been fond of, which is here it's called Inspect Presenter, but it goes back. I had this even in Strongtalk, 30 years ago or something like that. Basically, it lets you get at the widget that is showing you, that is displaying right now. So if I inspect the presenter, presenters in our UI parlance are basically like views, and I want to inspect the object that is actually presenting this thing to me. So if I click on that, I get another object inspector, but this one is on an object presenter, the thing that inspects objects. And it's of class object presenter, and I can actually look at the class in the context of the object. And I'll see there's a message here called a method called help text. And if we look at help text, let's bring up the help here as well. The help, yeah, we get these scrolling issues, but here the help is pretty much the same, except for the fact it says here, it says class object presenter, there it said class workspace, right? So other than that, it's the same because both of these are basically object presenters. And what does this, if we look at this, it starts, this is an object presenter, blah, blah, blah. And if you look here in this method, here it is. This is an object presenter, blah, blah, blah. This is basically the source that determines this help. And it's actually HTML. You see this HTML garbage like divs and breaks and all these beautiful things, right? And to prove that this is really it, we can go and edit it a little bit and make these things like into headings or something. And if I click that, see, it's turned into a heading, and it's a heading back there. It's a heading everywhere. We've changed the behavior. We changed the method, accepted it, and the display updated. Because another thing we're doing here, we do have a reactive UI, sort of in the style of things like React, whatever. Obviously, neither as ugly nor as robust as the stuff that an army of Facebook people created, but similar notion. So that's kind of a hobby horse of mine, because I'm into literate programming. And this, of course, is still wrong, because what I really would like is, of course, a live editor for this help text. That would be a rich text editor that I could embed Newspeak in and so forth. Since that's a lot of work, and this is a labor of love with very little time and resources, this is a handy thing. And the advantage is, of course, that I get a robust, compliant HTML processing, because all I have to do is call the browsers, HTML. I didn't have to write any of this stuff myself. So that's another nice thing that we have that's worth demoing, I think. What else? Going back to this window, if we click here, we get a list of all the classes that are loaded into the IDE. And you could think of it a bit like Smalltalk, except that it isn't, because Smalltalk also defines your global scope inside your programs, and this does not, because there is no such thing. Right? There's no global scope. But it is a way for you it's essential, essentially, when you're working with the IDE, it's essential to have this kind of place to find everything and get at everything. But one last thing I wanted to show you here, things like icons. So let's look at this one. So this is, again, a JavaScript object. We can see that it displays as the icon. This is something, similar to what Tutor does in Glamorous Toolkit, only much less robust and solid. But the idea is that, yes, these object presenters can have customized views, right? And so the basic, I was afraid of that, but I wanted to try it. Sometimes it works. There's a bug around here, and the system just crashed. This, in case anyone was worried that this is ready for prime time, I have a dirty little secret, which is it isn't. Basically, it needs a lot of work, and I don't have the time or the energy or the talent to work on to get rid of all these bugs. The robustness is not the biggest of our problems, actually. There are also strange performance bugs that are actually the biggest problem in the current version. Someday I'll fix them, I hope. But let's get further out here. Eventually, yes, to our slides. So that was the demo, including a crash. There'll be more demos as we go along. Let's see. Next slide. Let's talk about security. So this is where another less familiar buzzword came in, object capabilities. So capabilities, I sort of assume you kind of know, but I'll recapture the idea. The idea of capabilities, there were once upon a time, there were two approaches to computer security. One is access control lists, ACLs, and one was capabilities. And the world being what it is, they chose the wrong one. And that's sort of the standard process that you see almost everywhere is access control lists. The way I explain the difference is with a simple metaphor. Suppose you have a party and you don't want to have gate crashers. There are essentially two approaches you can take. Both of them involve placing a large imposing individual at the door to make sure that nobody who's not allowed to get in gets in. The question is, how do you check who's allowed to get in? So access control list is basically, there's a list of invited people, and the bouncer at the door checks every person who comes and sees if they're on the list. And if they're on the list, they get in. The capability approach is to say everybody has an invitation, and the bearer of the invitation can get in. And you don't have to check who they are. You don't care who they are. They just have to have the invitation. It's a bit another concrete example is tickets at a movie theater, right? Same idea. There is actually some token that hopefully is reliable and can't be forged and so forth, that signifies that you have the right, the capability of doing something, for example, entering a movie theater. So the idea that Mark Miller had was that objects make very nice capabilities. And so the object capability, or OCAP for short, model is that your objects are your capabilities. And we'll discuss that a little further as we go along. This is very much tied to one of the reasons we don't have a global namespace. We don't have a global namespace primarily for modularity reasons. It turns out if you do modularity right, then you are likely to end up with an OCAP security model as well. So again, just to mention that Smalltalk is not secure. We're doing things differently in Newspeak because we had these goals of things like security and being message oriented, and so that they result in differences because the language is not secure and is not really in its classical model secureable, right? Because in Smalltalk, if you call code, all bets are off. You can get at your caller stack, right, through the context and sender. From there, you can start looking at the heap. You can reflect on anything. You can get at their code. You can then change their code because you can get at the class and change it. Usually, you can modify all the code and all the threads in the running image in multiple ways. And that, surprisingly enough, is not conducive to security, because once you have malicious actors, the kind of model with all the power that Smalltalk gives you directly is a problem. And the usual approach, of course, is to throw the baby out with the bathwater and kind of shut down everything and make the system useless, which is the software we all use and love to hate. So the object capability model, basically, I'm going to go through what these 3 points are sort of its basic definition. The first thing, object reachability defines authority. Authority is the ability to do something that impacts something outside the program, or for that matter, inside the program. And the idea is that either you have an object that has the ability to do something, say write to a file, or that object has a method that'll give you another object that can do something, or transitively, so forth. So basically the transitive closure of objects, those you can reach, are the objects that have the power to do things, and those are the powers you have at your disposal. That's the basic model. So objects are this repository of power, right? They're the only way to do things. The other rules are no static state and no ambient authority, which basically means no ambient authority means that there's nothing that you can just reach out of the air and use that has power. Say, if you take a standard programming language, say Java, then anybody can write to a file, right? There is a security model that nobody uses because it's so complicated and cumbersome that it never got used. So without that model, you just have to mention Java util.file or whatever it's called, and you can write to files. And that's ambient authority, right? The same thing with network, with what have you, right? There's nothing you just reach out and grab things. The other thing you can't have is static state, because again, even if you had the authority to do something, now you've left it in some static variable, and then other parties that are running that can access that scope can get at that because it may have been left over, and it's not part of them. It's not part of an object. It's just out there. So you really can't have these things if you want to constrain things to really make sure that people have the right objects and only the right objects. Now, if you look at Smalltalk, what that means is you can't have global variables. You can't have pool variables or class variables because those are static state. And we don't have class instance variables either, because classes also, in some sense, tend to stick around, and for various reasons, we don't want them to be stateful. So those are all differences from Smalltalk, right? The other important thing is that, okay, if we combine that with the fact that we're message oriented, then we really need an access control model for methods. In Smalltalk, all methods are public and all instance variables are protected. They're limited to the object. Now we never touch instance variables directly anymore. And so we always use accessor methods. So now apparently everything is open and accessible, which is a problem, as I sort of mentioned earlier. And the solution to this is that we actually have an access control model, which is, again, not statically enforced by some stupid type check or something, but by the method lookup rules. And so by the VM. And that basically lets you have methods that are public or protected. And even there's a thing called private, which is a detail we'll see later. So these are kind of all changes. And at this point, I want to go and explain more by actually demoing stuff. So here again is our IDE. This time it's embedded in the presentation, right? We saw earlier that we could have Newspeak widgets inside of HTML and HTML inside Newspeak widgets. So it shouldn't be really surprising that the IDE itself, it's also accessed via a UI, and so we can embed it directly in the browser in our slides. So let's take a look at a few things. First of all, I wanted to show you nested classes just briefly, right? Because nested classes are, what we got from beta essentially, and they're key to making all this work. So this module, Collections for Primordial Soup, is the implementation of collections for this particular variant of Newspeak. And you can see there are classes here nested inside, things like list and map. So list is what you'd call order collection, map is what you're used to calling dictionary, and set is what you're used to calling set, etc. Right? And these are actually nested classes, and I can open it and look at the list class. There are methods like add all, right? So here, this, oops, yeah, sorry.
Just to be clear, you introduced this whole thing as a module, but isn't it really a class? Is it a class being used as a module?
Yes. Yeah, we'll get to, okay, since we were going to get to that anyway, I might as well. So there is no formal concept of module. Module refers to an instance of a top-level class. And module, if we start getting technical, module declaration is the actual top-level class. Why top-level classes act as modules is something I'm going to get to in the next 3 minutes or so.
Thanks.
That's a good point. It's too easy for me to sort of take things for granted and zoom through something that needed clarification. Thanks for that. What I was trying to clarify here was simply just, again, syntax. It looks a lot like Smalltalk here. There's nothing very strange here, except this stuff, which is a type annotation. It's completely optional. Again, one of my many ambitions that I've never lived up to is to actually write a functioning type checker for this, like in Strongtalk, but it's a bit trickier than in Strongtalk, but it can be done. As it is, I'm just in the habit of annotating things. I find it helpful. The other thing you'll notice is it says public here in front of the method. That is, again, the access control model we were talking about, right? So this method can be called by anyone who has a list object. And the ID shows these little green circles so that when it's collapsed, you know that it's public. If you look at somewhere here, this one is a non-public method, a protected method, so it has a yellow circle, right? So this is a nested class, and it's nested inside this top-level class. Now, there's a few things to remember about nested classes. First of all, unlike in Java, nested classes are properties of an instance. That just like instance variables or like actual instance methods, right, which are called with respect to a particular instance. It's very, very important. This is the fundamental misunderstanding that the Java folks had when they looked at beta. They didn't get this point, and it is total. And if you don't get this point, everything collapses. It's just a train wreck. And yeah, I made my name at Sun. I can't say cleaning it up, but kind of doing what I could for it afterwards when this thing started to unravel. So yes, nothing like Java. These things are properties of an instance. So if we have collections for primordial soup, the top level class, then if we have an instance of it, then each instance of it would be associated with its own copies of the list class, the map class, et cetera, right? In practice, we rarely need more one of these, but it is it is a nice property of the system that we can have multiple copies of this. So you could sort of think of these as like what you do in Smalltalk, you'd have a package or a category, but those are informal things and they don't have the same power as classes do. Classes can be instantiated multiple times. Classes create values that you can easily, pass around and store and so forth. So it's very different. But for now, I'm just showing you this idea of gathering these things in sort of this namespace-like manner to put all the collection stuff in one place. We'll look more in a moment at what the modularity properties of this are.
Gilad?
Yeah.
I hope this helps clarify it for people. I think that in Newspeak, classes are objects. And when you say a class is a property of an instance, you mean that it's basically late bound. I could have a different instance under the same name and get a different class as a result, or for the number 3.
All of this is true. I was hoping that since this is a Smalltalk audience, the idea that a class is an object was not too radical for people, but yeah, it's certainly the case. And everything that you said is true and accurate. So again, remember this idea that all names are late bound. This includes class names, right? When you reference, just as when you reference a variable, you are not actually talking about the variable. You're using an accessor method that could in fact be have a variable underlying it, or could be a computation in a method, and you can replace one with the other and no one would be the wiser. Same thing for classes. You could compute the class on the fly if you wanted to. You could store it in an instance variable instead. There's all these possibilities, because all we care about is the messages, the protocol, right? And so this applies to classes as well.
I love it.
So now I wanted to take like a simpler class and kind of go through and explain the modularity and security kind of stuff. So I'm going to load something in because it isn't part of the standard stuff. So here, we basically are going to access the file system and find ourselves some code that is good for this. So yeah, to do MVC, very popular example and simple enough that we can look at it. So to do MVC, just to show you what it looks like, actually, we can go to the Newspeak website and to the demos, and we can run to do MVC here just so you get an idea. So this is like here, we're going to explain slots, and we accept that. And we might explain imports, and we'll get that. And let's say that after I explain slots, that'll be complete. So if I look what's active, and what's completed, you can see explain slots is completed, explain imports is active, all of them are that, etc. So it's a very simple to do MVC app, right? It follows that there's a specification for these that a bunch of languages can have done to, can implement the specification to show that they have a decent UI framework that can do this, etc. So this is the same kind of thing. So let's look at the code for that, and then we can learn a bit about how Newspeak works. So this is class to do MVC. And if we look at this, let's look at what we have here. Again, it's a top level class, and it gathers together a bunch of classes that are related for some purpose. There's the UI. So presenters, as I said, are views. So there are a couple of presenters here. One is for the app as a whole. One is for individual items in the to-do list. Subjects are the closest, they're the subject of the presentation. Again, we had our own terminology for the UI. You could think of them sort of like controller. The thing, I don't like the model view controller terminology because there have been so many implementations and they've been so incoherent over the years that I never know quite what people mean by them. But this is roughly the analogy. The subject is usually the logic of the application is typically the subject. And then there's a third layer, which is the model, which is just data that doesn't know anything about the UI, right? In our case, to-do item is sort of serving as a model. So all these classes are here. You'll note that most of them are protected. They're yellow. They can't be seen from outside the application. Only one of them is actually exposed. So let's look at that one. To do MVC subject. And let's look at this. This is a nested class. We should see what a nested class looks like. So first of all, there is a syntax for classes. That's another big difference from Smalltalk. There actually is a syntax. Smalltalk has syntax for expressions and for methods, but there's no syntax actually for going above the method level. So we have a complete syntax that's useful for various reasons, not the least of which is that it's easy to put into standard source control, for example. So some of this should be fairly obvious. Yeah, there's a class. Hello, yeah, and it has a name. It's public. Again, what that tells us is that the accessor for this class, this is the point where I was going to explain what Dave just said, but it won't hurt to repeat it. Given when we define a class as a nested class, there's going to be an accessor for it, which is how everyone will actually be able to get at it. And whether that accessor is public or protected or whatever is determined, again, by having these access modifiers, just as we saw with methods. Now, the next thing I'm going to show you is, right, see these two vertical bars, right? They look a lot like declarations of temporaries. In fact, they're variable declarations, except that since we have a syntax, we also declare instance variables in the same way as we declare temporaries. But that declaration isn't quite what you're used to in Smalltalk. There are two variables here, filter state and to do subjects, but there's more to them than just listing their names. So again, they can have a modifier. For example, filter state is public. That means that the accessor methods that are going to be created automatically for it are going to be public. There's a type, which is optional again. There's this binder. This is part of the declaration. Because it's sort of assignment-like, this tells us that this slot is mutable. And therefore, if it's mutable, it's going to have both a getter and a setter, right? And then there's an expression that is initializing it. In this case, the initial value is a symbol, and that will get initialized when the object gets created to this value. Okay? So it's going to have automatically a getter and a setter, and those are going to be public methods. Now, to do subjects doesn't have a modifier in front of it, so the default is protected. By default, you don't want to publicize things. So it's only going to be accessible within the object. And the other thing that's different is the equal sign. This is definitional equality, like in mathematics. This is not a message send, this is a declaration, a part of the syntax that tells us that this particular variable is immutable. You know, when we say equal, we don't mean like C equal, which means a sign. We mean, we mean equal. And so this will never change after it's created. So it's going to be initialized to again, this whole expression here, but it's not supposed to change. And how do we enforce the fact that it won't change? Well, we don't create a setter method. So it's only going to have a getter and no setter. And there isn't going to be any way for you to set it because you can't access it anyway, except reflection, of course. Reflection is a separate capability, which by default your program doesn't have. And we'll explain how that works again in just a moment. But this is how essentially instance variables work. And the question is, of course, okay, they're initialized when the class is created. How does that, when the instance is created, how does that work? So we're going to create it. If we create an instance, we have a class object. It's going to be accessible via an accessor method, and we'll get to do MVC subject. And we'll send it a message, of course. The class will have a class method, which is known as the primary factory, the thing that actually creates instances. And this syntax here says it's going to be, we give basically a method header, a message signature that says what the factory method is going to look like. And in this case, it's on model. We create a subject on a model. And when we call that method, we invoke that method on to do MVC subject, it will allocate an instance, and then it'll invoke the initializer on that instance. And the initializer is defined by the stuff we have here, the initialization of these instance variables. Now, there's one more twist to this. This works a lot like constructors actually in most languages in that respect, except that they're not constructors, right? They're not static entities that you can't override or change or whatever. They're actually methods, like class methods in Smalltalk. So that avoids the essential problem with constructors. But they are similar to constructors in this way, that they basically will go up the class chain, right, and initialize everything. So when we start to initialize, we're going to start with superclasses first. What's the superclass? The syntax tells us that subject is the superclass. And this here tells us that we're going to call the initializer with the same value that we passed in, right? So subject has an on model, it so happens as well. And that's how we're going to pass the arguments up the initializer chain. So this is a lot like constructors in other languages in that respect. But unlike constructors, you can change these, they're a method, they're part of an interface and so forth. So this is basically the most complicated part of the story of how you initialize things. And it does have advantages because, again, if you think of security, the Smalltalk protocol where the class method calls an init method on the instance has this problem that this initialize method is a public method that anyone could call. In an insecure environment, that means that I can call an object you gave me and set it back to its initial state. Anyone can do that, right? We can't actually have that initialization part of the public protocol in a secure system. It just doesn't work. It's also true that you could have errors where someone accidentally initialized something twice or forgot to initialize it. None of these things can happen here because once you write this definition, you're guaranteed that every object will be initialized according to these values, and its subclasses will also be initialized. And once it's initialized, it can't be initialized again. So all of this is a bit of complexity, but it's there to basically lock down things and make sure that we can do things in a secure and robust manner. So you've learned a bit about classes. Now we can look at the enclosing class, which we had before, to do MVC. And actually, no, we want to look, there's one more detail I wanted to show you here. So this method, here's a class method, right? We have instance methods displayed here. And again, this is different from the Smalltalk browser, right? This is linear sort of tree browser display. Again, something we stole from Self. And many, many years ago, we first stole it into Strongtalk and then stole it further here. And it has the advantage that you can look at multiple methods side by side kind of conveniently. But what I wanted to show you here is this method new, because if I want to create a new to do MVC and I don't want to give it explicitly to call on model here and give it whatever the model is, the model actually is a list of to-do items. And initially I want one empty, it's convenient to have a new method, which will just create it empty. And what that does is in turn creates on model with a new list, right? So here, this is an example of an implicit receiver, which is Self. It's the class object because it's a class method. And list, well, the question you should be asking is, where did list come from? It's obviously not here anywhere, right? And we don't have a global scope. So where does it come from? It comes from the enclosing class. You can see here, red means private, by the way. So here's again, the class definition of the top level class. Being a top level class, it's named to do MVC. It doesn't have an access modifier because it's not part of anything else. And it has these 3 instance variables, one of which is list. And being an instance variable, it'll have an accessor method. And that accessor method is what we're getting when we actually look at the new method here, right? We're calling that access method, which is available to us because it's in the surrounding scope, which is a bit of a lie because there is no, it looks like lexical scoping. It behaves exactly like you'd expect with lexical scoping, but this is of course a dynamic lookup. And this is a case where the receiver for the list method is implicit, but it isn't Self. It's the enclosing class's Self. It's the object of the instance of the enclosing class that this class is tied to. So, okay, oops, I didn't want that. Okay, now the only problem is I lost to do MVC because I refreshed my browser. So we'll bring it back. Sorry about that.
It would help if at some point you have a diagram of the lookup algorithm here. I'm getting a little confused, sorry.
Oh, well, Dave, you're just not as sharp as you used to. It's very easy. Just kidding. No, I have no intention of going through that actually in this presentation unless if we get to question time. The lookup algorithm is about 10 lines, but I do not have a diagram, and I I can sort of explain the idea. It's not actually, those details are not what is actually crucial at this moment, actually. So what I do want to,
Never mind.
we will, if in question time, I think I can make this clear, but that's not what I'm trying to do here. All right, so we were here. So the question is, okay, so list, obviously it's the easiest way to think about this without reference to lookup algorithms is that, this is literally, if you print this out, right, you'll get, there's a syntax for the class, and this is all of this code, including these classes, are inside it, and it's lexical scoping. You can see it because it's in the surrounding definition, right, this list. And that's what we call. But the question you might have is, okay, where did list get its value? The list is the list class, presumably from the collections implementation. How did we get at that? Well, obviously we initialized it with this expression here. And so we sent a list message to something, to this sub-expression, right? And this looks like we sent a collections method message to somebody. And you'd be right to assume that we got a collections object like the one I showed you before, and it has a list method that actually returns me the list class that is part of its implementation. So we've kicked this scan down to the point where, well, we sent this message to P, and where does P come from? And P is the formal parameter to the factory method, right? So when I create an instance of to do MVC, I call using platform : and I pass in an object that is supposed to support a collections method that will give me a collections object that supports a list method that'll give me the list class, right? So this essentially is my import mechanism. I get things by passing in objects from which I can then extract the values that I need, which in this case happen to be classes. I store them in local instance variables of the top level class, which is essentially a module. And then I have access to them within the class. And since who I import is really an implementation detail that shouldn't be exposed to anyone, even to my subclasses, then I mark these private, which means that these accessors are not available even to subclasses. They're only going to be allowed inside this lexical scope. And we do the same trick with two other things that we're getting. Presenter, which is the view class, and subject, which is, as I said, the thing like controller. They both come from the UI module. So again, we ask the platform object that we got in, we send it the message hopscotch, which is the name of the UI. Hopscotch is divided into pieces, or at least it used to be. So we get the core piece, and then we ask for presenter and subject. And what's good about this is that I know what my dependencies are. These are the only things that are being used in this code, right? Nothing else can be accessed because there's no global scope. Unlike in Java, I can't have something buried in here somewhere in the code that can go grab something like the network or the file. This isn't using files. It can't ever get at files because it didn't actually try to get them here. And in fact, what it got was what I gave it through the platform object. I can also give it a different platform object that's attenuated. Say I want a dummy UI that is easier to test programmatically. I don't actually need to bring anything up on the screen, but I want something that will respond as if it were a UI through program calls or something. I could give it a different implementation of hopscotch here and run it, or I could mock up something for tests or what have you. It's entirely dependent on what was passed on it from the outside, which is different from imports, where imports basically are in standard languages are a mechanism for you to go out and grab whatever you want from the outside world, right? And so I know what my dependencies are. I know for sure that they're not getting anything else, right? And so the effect of this is that this top level class is a sandbox, right? Or rather it is in a sandbox. The sandbox is determined by the arguments that it gets from the outside world. It can't get at anything else because there's no global scope. There's no static state that would be hanging around that it could get at from some different time or place. And so it is essentially encapsulated from the rest of the world, right? The only thing it can do is use the objects passed into it, which are essentially capabilities, the object capabilities that are passed in that give it the power to do things. So it can't get at the network, can't get at files, it can't do reflection either, because unlike in Smalltalk, reflection is not just a bunch of methods on your class that you can get, or on anyone else's class. You need actually to have a separate capability for that, a separate basically module that can do that, the mirrors module. And if it's not here, it can't do reflection and it can't bypass things. It can't call the FFI either, because calling native code, or in this case, JavaScript code, again, is something that's in a module that has to be passed in. So it really doesn't do all that, because once it's done imported these, this initializer goes away and it can't access the rest of the platform. So this is the core of both the modularity story and the security story, right? Is this absence of any global or global scope or static state. So that's one of the most important things we wanted to cover here. So anything else? Yeah, let's see. Couple things. Yeah, I did want to give you some better picture of how this all hangs together, right? How you might write some code. So one of the big differences, again, as a result of this modularity story, a deployment, which has always been a sort of sore point in Smalltalk, becomes very easy. So the reason there's a slide and not just a demo, because some of these things hold universally, except people don't realize them. So if you think of, an executable, like a.out or whatever, or a .exe in Windows or whatever you call it, an executable, it's just a serialized object. It's a serialized object that the operating system knows how to deserialize. When you load in an operating system, that's just deserialization of certain known formats like ELF or dwarf or all these executable formats. But it's just an object that you're deserializing. And that object has a protocol or an interface that it supports, which is basically where, what's the entry point? Say main or run or something like that. And the operating system knows to invoke that, and that actually runs the executable. Now, the fact that it's not thought of usually as an object, and that there's people out there saying, that they don't do object-oriented programming, they do functional programming, they couldn't make anything work if they didn't have these objects at a minimum, right? It's just confusion, because that is the basic story, that these things are objects. It's just not clearly realized. So the deployment model in Newspeak basically is derived from these insights and would be natural in any object-oriented system. So I could show it to you here, I suppose, but we could go back and look at it, because we want to look again at to do MVC. So let's look, where did it go? Oh, it's restarted itself. Oh yeah, these slides have a tendency to reload everything. There is a problem with keeping the ID inside the slides, in the sense that it restarts all the time. So we might as well do it here. We're going to get an app again. We might as well do MVC app again, wherever it came from, these two guys. And we'll look at to do MVC app. So before we looked at to do MVC, now there's a standard story we have, which in this case is maybe slightly overkill, but it's good to show how you deploy an app and how you use these modularity constructs and actually get something to work in this whole scope in this whole context of not having a global scope. So to do MVC app is, again, a class. It's top-level class, and its factory is called package using, and apparently it takes something called a manifest, and it has one instance variable, to do MVC, which it gets out of this manifest. And to do MVC, of course, is the to do MVC class that we saw earlier, right? That's the implementation of to do MVC. So what are we going to do with this thing? Well, to do MVC app is the class of your quote unquote executable. You could in fact turn it into an actual executable. It is instances of this class are this object I talked about, the object that you can load and run. And therefore it has to have a protocol with a standard entry point. And that's what the main args method is. So what does this method do? If you call it with a platform and args, which could be an empty list, this could be some whatever command line arguments you wanted. In this case, they'd be empty. You'd instantiate to do MVC, right? To do MVC is the actual implementation of to do MVC. And it had this factory method called using platform. So you'd call that and pass it the platform that you were passed. And now you'd have an instance of that library of the to do MVC class. You'd have the to do MVC module, technically speaking. Now that module is code that knows how to, given a platform that has UI and a list and whatever, it knows how to put up a UI for to do MVC. But it doesn't actually start the UI. Somebody has to start the UI for it. And that's what we do here. We ask the platform, again, platform hopscotch is the UI. We get the class hopscotch window that controls the overall UI, not just the presentation of to do MVC. And it has a method called open subject, which will take a subject instance and start the UI for it. What subject instance do we want to show? Well, we want a to do MVC subject. That's the one that actually the nested class inside to-dos that actually is the controller for this app. So we instantiate that. Where did we get it from? From the to-dos object, which is this local variable, temporary, that we just initialized to be the to-do MVC module, right? So basically getting the class from manifest, that's why we can access it here, right? Because we have no global scope. And we'll explain where manifest comes from in a moment. But you've got manifest, you extract to do MVC, now you have a to do MVC class, which you can instantiate. With that instance, you can extract its subject, which is the thing that you need, the controller for your application. And then you can have the UI open that subject, and that'll start up the UI and display it. So that's how the app gets started. The only question is, how did we actually get this? Well, manifest has to be sent in, right? That is something that someone has to provide me. It's an object that basically has to have an accessor for to do MVC. What might such an object be? Well, the IDE, as you might recall, has this namespace of all the things loaded into it. That's essentially a map. And if we look for manifest, let's see, manifest, right? So there's a class name manifest, and it has a does not understand, and it has a namespace variable. The namespace variable is going to be a map, and it just turns a map into an object that you can do lookup for, right? Every key in the map can be sent as a message to this thing, and it'll respond. That's what it does not understand does, right? It looks up in the map, and it specifically also looks up things both in the regular top level map and in the icon submap that I showed you earlier. So that's how a manifest works. It's just an object that will look up classes in the IDE's namespace. Now, if I were to go back to, let's look at the history here, right? And to do MVC, right? If I pass such a manifest object into here, then I could get my to do MVC app and run this thing. Now, the point is that once I have this object instantiated, it has all the pieces it needs to run, because it has the to do MVC code in its instance variable. And if I were to serialize this object, I would then have something that if someone else decided to deserialize it and then run it with a platform object, they could start up the app. And the nice thing about it is all it has is to do MVC, right? Because it doesn't need all the other stuff in my IDE. right? It's not like an image where I have to worry about what's in the image and do I want to really deploy all this stuff and carry all that extra baggage with me, right? We literally have only the app, only the code we need because, and again, because classes are stateless, it's not carrying anything else. And because there's no global scope, it's not tied to anything else that might be hanging around there that might be dragged into this mess, right? It's just the code that we wanted to deploy, serializes an object. The Newspeak system knows to deserialize such objects, give it a platform object, and call main : and run it. And that's how essentially how we can deploy things. You can deploy, how you serialize controls where you deploy it to. For example, you can deploy it, in principle. We don't have the engineering to do this, but you could turn this into an actual executable binary, or you could turn it into something else, depending on which. You could turn it into a Smalltalk image, for example. But basically, the point is that we can isolate things because it's a modular system, and that's sort of the deployment story. So at this point, I don't really want to do any more demos unless there are questions. I'll tell you a couple more things, and then we'll kind of open up for questions. So basically, this is a VM written in C by Ryan Mackneck. It compiles to WASM. That's how it runs in the browser. There's also a version that is actually a transpiler into JavaScript, which needs work. It has advantages and disadvantages. One of its big advantages is it actually performs a lot better because, a lot of work has gone into the JavaScript implementation, and it's actually a lot faster than a naive interpreter, especially since WASM isn't actually good with interpreters. It is much harder to get the proper semantics. In fact, for a long time, it was basically impossible. I think JavaScript has now reached the point where with some work, we actually could get the proper semantics. But when that'll happen, I don't know, because most of the time it's just me and things move very slowly. So if anyone wants to help, let me know. I'm just going to put up a slide for credits to some of the people who worked on this. And these are the people who at some point were paid, either back in time when we had funding, or later some of these people were interns. And occasionally I could get an intern paid at other jobs to work on this. And then a bunch of people did stuff volunteering. Some were students, some were just people who volunteered. Some did more, some did less, but they all have I appreciate what they all done. And yeah, that's the presentation. And I can hopefully clarify or answer any questions or show more stuff that this can do if anyone's interested. And thank you for sticking with me this long.
Thank you, Gilad. That was quite interesting. Now, does anyone has any questions? If so, please unmute yourself and ask away. Possibly not all at the same time.
Yeah, I have a question. A simple one.
Mm-hmm.
Is it possible to load Smalltalk code in? What's your file out format looks like?
Okay, okay, so actually I'm going to change what I'm sharing because this is just because I want to actually show you like Emacs so you can see that. So let me see how, where's the thing that controls the sharing? I'm going to stop the share for a moment and share something else, or just share the desktop a minute. Let's get rid of some stuff here. Share. I'm going to share my desktop, and then I can show you more stuff. So here's can you see this? Here's Emacs, and what I'm going to do is move some stuff so you can see this properly and get a file like. So you guys see this? Is this legible?
No.
Very small.
It's not legible. Okay. Let's see. What happens if I do this?
Yeah, much better.
Okay, let me widen this so it's a bit more civilized. Guys away. Widen this. Move all these things. And okay, so this is vaguely plausible. Too many things to move. Right, so this is the actual syntax, right? So as I said, this is not like Smalltalk. There is a syntax for classes. And the syntax tells you which variant of the language it is up here on top. This is a relic that used to show you what category it is, but we don't care about it anymore. Back from the day. So the Squeak version let you interoperate with Smalltalk very smoothly. Basically, you were part of the same thing, but that was not bootstrapped. It was, in fact, we were completely tangled in with the Squeak implementation. And, we were using Squeak strings and various other things. And really, you couldn't, it was difficult to bootstrap that. And there were other reasons why we left the Squeak implementation. So this thing is actually bootstraps, but Newspeak code actually comes in like this. So this is stuff you saw before, like the class definition, but then there's a segment that starts to have the nested classes, and in them there are the methods and so forth. So all of this is basically regular syntax. So there is no file in format. I always found file in format to be, one of the most unfortunate and embarrassing things about Smalltalk when I had to explain this to people who weren't Smalltalkers. And so there is no such thing. Yeah. And in this implementation, the web-based implementation, there really isn't a way for you to use regular Smalltalk. In the Squeak implementation, they interoperated pretty seamlessly, but that's not really viable anymore. So that answered the question, and perhaps also
so this kind of code you can load into the web application.
Yeah, this is literally what we loaded, right? So when we actually did this, we went to the file browser and clicked on to do. This is the file we loaded, right? That's exactly what we did. Yeah.
Very cool. Thank you.
So Gilad, I want to ask sort of a macro level question that's suitable for my comprehension abilities at this point in my life. And that is...
oh, that hurt. Ouch, sorry, I apologize. But you know me, I'm vile. It can't be helped.
Well, I use the word confusion, and sometimes I use that as a criticism, but I didn't mean it this time. And that's probably what you're reacting to. The question is, when one designs a programming language, one makes a number of design decisions. And some of them are consequences of other decisions, and some of them are independent. And you listed some of the key characteristics of the language at the beginning, but I'd be really interested in, what decisions sort of came first and what were consequences and what were independent. I suspect that security was a key initial decision, but whatever you could do to lay out the design decisions in that sort of causal network would be very interesting to me.
Okay, so the first and really dominant decision was modularity. Security was in the background there, and the idea of using objects as capabilities as well. But the interesting thing to me is we started with, let's make it modular. Let's see what we can do with making things modular. And the fact that it just turned out to be an exact fit with the security story was sort of this aha kind of moment that kind of, oh, wow, it actually do this, and now it's a sandbox. It just fell out, right? Basically, the two key decisions were we weren't going to have a global scope, and everything was going to be messages, right? So it's only different from self in that one detail about global scope. There's no lobby, basically. And if you got rid of the lobby, as you pointed out to me before, then self would have essentially the same properties. So that really was the leading thing.
Okay.
And basically these two things, everything falls out. The fact that, you know, it's you still have to figure out, okay, obviously we're going to make everything an object. And it turns out that falls out as well. Because once you make it message oriented, everything is going to be an object, no matter what you do. Because there's nothing else you can interact with or act on except things that support messages, that have an interface, which are objects. So even though that was sort of a goal, it turned out it isn't necessary to have it as a goal. It just falls out from essentially saying all the names are late vowed. Right?
This is
so
very
those two
interesting.
decisions dictate almost everything, except, you know, what do you do actually? They sort of dictate, but they don't prescribe what you're going to do about nested classes, right? Because with nested classes, essentially, once you've made these decisions, there's no static state, and yet you need to share objects among other objects, and you need some way of doing this. So nesting is the answer we came up with. I'm not sure if there's another answer, honestly, but it dictates the nesting. And then, of course, I think very early, before we really were working on Newspeak, there are talks I gave about synchronization where I proposed to have something which would have a top-level module construct that was sort of similar, and it wasn't classes. The fact that I could unify with them with classes was something that when we started working on this, that clicked and say, oh, I don't need anything more than classes. I just need nested classes. And then, of course, it turns out to be like beta. So everything, except for rather detail, almost everything falls out from that, right? There are details. Okay, how are you going to initialize? Okay, that's sort of where Scala came in a bit, and
okay.
it's more complicated.
I'd like to hear more about that. I'd like to hear more about classes, but I'm stuck wondering when you say modularity, what would you hope to gain from implementing or building a language with proper modularity?
Well, one thing I hope to gain was just good software engineering, that things are decoupled, things don't impact each other too much when you change them. Another thing I wanted to gain, deployment, right? This has been a huge problem in the history of Smalltalk in particular, that the images is fun, wonderful thing, and yet you know, it's sort of entraps you. It's golden handcuffs on steroids. It's more like a whole golden garden where everything it's wonderful, but it's really hard to get out or to take something out. So deployment, and yes, security as well. It turns out that modularity, if you do modularity right, security almost pretty much follows.
Great.
Again, that dictated access control, for example. Modularity also dictates access control in the sense that you want to keep things public or not.
Well, thanks. This is fascinating. I'm going to let other people, you know, have their turns, and if it dies out, I may ask some of the more micro questions. But this stuff is really golden. Thanks, Gilad.
Thank you. So there are the questions in the chat, but I hope to get to all of them somewhere. But maybe if there's any, yeah, there are hands raised. So am I administering this, or is Giovanni administering this?
Giovanni and a few others. I'll go with a question. I've raised my hand. I can read the code there. So it says list with uppercase. You're getting like you're going to use the list. So you say P collections list. So those are all messages where you're extracting the list, and you're going to be using it somewhere later on. And that's great. What I slightly confused is with the other, or very confused, is in your first example, you were saying the primordial soup, you have like a collection class, and then you had nested there, you have the list class and a few others. So it's like you were defining methods for those classes.
So the collections library. So I do have this is not in the web browser, but okay, I'm gonna put
what I'm trying to get
somewhere, and I'm gonna show you the code. You can see this guy, right? Newspeak ID here.
My question is whether if you are nesting classes or you having to repeat the definition of list across different places, that will go to duplication, which surely I must be.
So, yeah, so there's got to be a misunderstanding here. Right?
Yes,
so,
yeah.
Right. So, okay, let's tell me if this is legible. This is another. So another way of running Newspeak is in this Electron app. That's the same code base. So I actually have one open here, and maybe it's too small because I'm sharing the whole desktop. Can you guys see that?
I can see that. Yes.
Really?
Maybe.
And right. So the Emacs is here, and I believe I'm sharing the whole desktop. So you should see this as well, where my cursor is.
If you did Command plus a couple times, I think it would be perfect.
Okay.
Yeah.
How's that? Okay.
For me, that works.
So this is the collections module that you were referring to. This is where the definition of list is, right? There is the class list in here, and likewise map and all this other stuff. This is where the code actually is, right? What you're doing here in this other module to do MVC, the one that's in the Emacs browser, is you're importing that effectively. What happens is when you instantiate to do MVC, as we saw in the to do MVC app, you call this method and you pass it a platform object. The platform object was built so that it actually has an implementation, an instance of this module, collections, that it allows you to access through the collections method. So I access that and I call this and I get the list class. The list class, by the way, the way the class accesses work is that they lazily compute the class on first access and then cache it.
Fine. Makes sense.
Okay. And so I'm going to get that same list class anywhere I'm using the collections from the same platform. Right. So the only thing I'm doing is that I do have to import it wherever I want to use it. I do actually have to get it. I have to ask for it. Right. It's not just in scope. Right. But I am not replicating any code or even replicating the class objects necessarily, unless I want replicas, which I can. But typically, but in a thing like list, I don't. I just want this one implementation. So now what happens when you deploy is it depends what scenario you're deploying to. If in a better world, somewhere there's a wonderful alternative universe where this must be true. Newspeak is a widely used standard, and you can rely on the platform object being there, and all you actually have to serialize is just like to do MVC app, and then just like you have a Java class file, and you assume that Java is installed and it'll load it, and all the other stuff will come with it, right? In reality, that isn't the case. So you typically want this thing to be completely standalone. So what you really want to deploy is a serialization of this and the platform with all the pieces that you are using from it, which is not as compact. But still, compared to modern software, all of this is 2-3 megabytes for everything with the UI and what have you, right? So it's not very large. But in that sense, if you have multiple Newspeak apps, each one is sort of traveling with its copy. So I don't know if I've answered your question or a different question.
No, perfect, yeah.
Okay, so who's next, I guess?
I think I am. So this is really nice. I've heard you give a talk before on Newspeak, and it didn't quite click. But this has been really great, and it looks fabulous. It looks really interesting, and I really appreciate your characterization of the history and the shoulders upon which you've stood. I really think that helps to put it in context for me. So I'm working on an alternate Smalltalk VM with completely message passing structure, and I'm aware that Newspeak has run, at least on the open Smalltalk platform. And so what I'm wondering is what features or what do you use for Newspeak beyond beyond what what Smalltalk does.
Somebody should mute.
It was Tuber, I think he has.
Yeah.
So the question is,
Right.
what features, or what does Newspeak need in terms of a VM beyond what Smalltalk needs?
Okay, yeah, that's a great question. So getting
I'd love
in a
to
little more
implement it,
detail.
frankly.
So there have been several bytecode sets, right, over time for the Smalltalk implementation, and most people, I think, like Squeak.js, whatever, they're still on essentially the v3 bytecode set.
Right.
Now, the v4 bytecode set actually incorporated extra bytecodes, which were what Newspeak needs. And unfortunately, most people aren't using that, and it's separate, and therefore it isn't well tested. And that's one of the reasons there are multiple reasons why we got off of Squeak Smalltalk. One was it was sort of very hard to bootstrap out of that. Another reason was just, it's natural to put this on the web, and so it's nice that I can have web pages to do this and so forth. But a third reason was that it wasn't working well because it wasn't maintained properly, because no one was using it, and therefore it wasn't being tested thoroughly. And therefore, as the rest of the platform evolved and Elliot did work on it, things started to break randomly, and it just became less and less reliable. And so in principle, the v4 bytecode set working correctly, which it actually works less well than it used to because everything atrophies with lack of use. That is what you need. So there are bytecodes there essentially for dealing with the nesting and dealing with the lookup. So if you implement it directly on Smalltalk, you find the overhead of accessing classes and stuff and all the stuff through these levels of nesting and explicitly without the VM support for that really starts to slow you down significantly. The other part is once you have access control, the lookup. So the lookup does essentially in the v4 bytecode set, there are multiple bytecodes for lookup that are cognizant of access control, whether it's public or not, and also of the scoping of how they look. Because Dave asked this question about the lookup algorithm. The essence of the lookup algorithm is you look up the lexical scope till you reach the top level class, and if it isn't there, you look it up in self.
Is there a difference between class methods and instance methods for the lookup then?
No, they're separate objects.
I'll ask that question when it comes back around to me.
Okay.
So
basically, yeah, there is subtlety, but basically there isn't. There really isn't. There's nothing special about classes. What is special is the access control. So the actual byte, you could go through what the actual byte codes are, and maybe it would be clearer. But basically, it's a handful of byte codes. And the byte codes, basically they implement the lookup algorithm. The lookup algorithm is 10 lines, and it's not. So, but it is a different in the VM.
I'm not building a new bytecode interpreter. I'm building basically a message sending. So everything is message sending or primitives, and primitives are message sendings too, obviously.
Right. The thing is that what is message sending, right? Message sending involves method lookup, and so right. Typically there,
so there's a different message lookup,
bytecode or something else.
So what you're saying is that you have a different message lookup than the default Smalltalk. Although, so you don't look at the instance variables first, you look at all the scope variables first, including the enclosing classes. Is that?
Well, you start from the receiver, and before you look up the superclass chain, you look at the enclosing objects.
I see. Okay.
And when you're basically which the most intuitive way to think about it is a lexical scope, even though it's
Sure,
actually a
got it.
dynamic lookup. And
Yeah.
if it's not in the lexical scope, that is, you went through all the enclosing objects, say you were nested,
Okay.
whatever, then you're going to look up your chain, and just
Okay.
your chain, not the enclosing objects chain, and
Yeah.
you're going to basically see if you can find it there. And every time you look up there, you also have to be cognizant of, oh, was it private or protected, or there's a few other twists to this. And so there's actually a number of bytecodes that correspond to, essentially they each correspond to a different syntactic form that you'd actually have in the language, where the rules would be slightly different.
Okay.
I think that's enough for now, unless we can really go through this, but there are other questions.
Okay.
So
Thanks.
I
Appreciate
guess
it.
Tim is next.
Sorry, just unmute myself.
Yeah.
I had a slight question. When you're importing things like list and presenter, what if you wanted to import all the collection classes? Is there some concept, like would you stick them in some sort of dictionary, and then when you're referencing those classes, it would be some method send to the thing that you've got to then get the class that you want? Because I think it could be painful to have to list every single one of them. Sometimes you do want to sort of get all of the collection classes or something like that.
Okay, so several answers to that. One, so obviously there's no, since this is actually literally the mechanism I showed you, there's no wildcard or anything like that. You could, of course, choose to import the collections module, right? You could have said something like here, I'm just gonna sabotage this and say, right? You could do something like this, right? And now you've got the collections module. Generally, this is, it's very rare, and I've never had a use for this, to be honest. But unless you were doing something very meta, then it's very bad style, because now you basically have this vague large dependency, and unless you truly need every last piece of it, then you're bringing in things that you don't really need, and you've sort of lost control of what's being done here. So unless you actually are really doing something with the whole module for some reason, it's very rare that you need all of the collections classes in one module, I would say. And there aren't that many of them. I'd still recommend just take them one by one.
Like even like a UI thing, because often you get lots of little objects with UI stuff, don't you?
Okay, so that's an interesting example of how does it actually work. So the UI here, we implement, you get, say, presenter, and there are not a million, but there are lots of UI widgets, right? There are buttons and links and all these things, and you'll notice that, in fact, they are used. The to-do MVC here, it had a checkbox and it had buttons, and no one's imported button or checkbox or anything. The way the presenter class works is that it has protected methods that are accessors for all those widgets. And when you actually define your own presenter, like this one, you subclass presenter, and you inherit all those accessors so that you can actually get, for example, here, button, right? This is a bit of code that basically creates a button with an action which is defined by this particular block here, right here. And so what happens is that the button : action : method is inherited from presenter. And it is basically an accessor that, because it is in the module, the UI module, and has in its scope, its sibling class, which is the button class, that presenter gets you that essentially through inheritance. Because for UI purposes, everyone needs all these pieces.
Okay. No, yeah. So in practice, it does work out all right then. Okay, that's interesting. Yeah.
Yeah.
Thank you.
You're welcome. Christian, I guess you're back on the list.
Another simple question. So, since everything is method sent, how and why are you distinguishing the classes? So, first letter uppercase, is that enforced? Is that a style? Is that arbitrary?
It is a style. It is not enforced, I never thought it may be a habit so deeply ingrained, which I got in some language somewhere. I can't quite remember its name. You could argue that that they could all be, lowercase and no one would be harmed. That's true. I do find it useful to know that it is intended to be sort of something class-like, even though, yes, it could be a factory object that doesn't have to be a class. And in that case, I'd still name it uppercase because it's intended for creating instances. But that is a style thing, and there's nothing in the language that cares.
No, I'm fine with these kind of things. I often use uppercase methods actually, which looks funny at first, but yeah.
Again, if you were doing a method that, say, computed a class on the fly or produce a factory object, then yeah, you would probably use the uppercase as long as the style that we are using is pretty much ingrained, it's in the platform and everything, means that classes or class substitutes are uppercase, but you don't have to.
Yeah. Thank you.
Did we miss anyone? Someone said something about graphics classes.
Yeah, that's me.
Oh,
I saw some graphics classes in your scrolling by, and I have an interest in doing graphics in the browser. And I just wondered what sort of graphics are supported and in what way.
Okay, so you can do anything that the browser can do in principle, right? You can call out to JavaScript and do whatever you want. In particular, you can use Canvas and work at that level. And there's even a demo of something that does that. But my philosophy here is, I want to pave over all this stuff. It's all a gutter, and I want to pave it over. And so I don't want to see any of this if I can avoid it. Sometimes you can't. And so there is this UI framework called Hopscotch that is essentially an evolution of something that Vasily did many years ago. And that's the stuff that we actually are using to implement the IDE, for example. And it's sort of a high level, reactive framework. But you can, if you don't like it, for example, you think performance isn't good enough, which is certainly a valid complaint, you could call the DOM directly. You could bring in, you could have a JavaScript page with React and call React if you wanted to, or you could call Canvas and write to Canvas. All of those things are possible.
I'm trying to do as little as possible in JavaScript and as much as possible in Smalltalk.
Right. The other thing is, okay, let me, since I'm sharing everything on the only downside of this is I have to keep looking sideways from the camera, but and I have to keep moving things around on the desktop, but that way I can share different things. So I think I can find here, right? So yeah, there are all these widgets that, radio buttons and what have you. They might have, do we have more of these demos here? Particles. So this is basically writing to Canvas. And so, I could probably find it, the source for it, but I don't know. Let's see. Let's see if I have particles here anywhere. And particles. So this is the particles class. And what does it do? Well, it has a nested class world, and it just instantiates it with, the size of a point. So world probably has most of the action here. And there's a world presenter, which is, calls canvas, right? So you can do things at a lower level if you want to, and there's advantages and disadvantages to all these things, and it's a matter of what you care to do.
Sure. Okay. Thank you.
Let's see. Okay, Michael, I guess, is next. If I'm raise his hand, is he unmuting or does he not hear me? Or did he give up?
Michael Bateman. No.
Okay, he gave up.
Let's move on to, is that Graham?
I've just been, thanks.
Oh, sorry. Francisco, I think you raised your hand again.
Yes, I raise again. Yeah, my question is about everything is initialized. So do you take, can you have slots with nil values, or do you prevent nils from happening?
Okay, so the rule is that you can in fact write, let me rephrase that. You don't actually have to initialize an instance variable. If you don't initialize it, if you just write the name of a variable, like as if you were writing a Smalltalk temporary, right? Then it will be initialized to nil and it will be mutable.
Okay. And then, so the nesting, so we have an inheritance, so that's the way to share code or to inherit code. There are no traits here, no? Or
no, there are no traits. Okay, so there's an interesting point to be made, which that essentially mix-ins fall out of this model automatically, because once you make everything a message send, the superclass clause is also a message send, and so you're late binding your superclasses, which means that you can then easily override them to produce a new class that has the same body, the same stuff that you wrote in your class, but is bound to a different superclass. Maybe I should try and explain that better, huh? But basically, so you do have mix-ins, and again, there's parts of the language spec that were implemented in Squeak and not implemented here that let you play, made it just syntactically a bit easier to play games with mix-ins, but I sort of, the talk I gave at the California meetup, actually, I spent a lot of time on this, on how you could leverage this, because you can take, let's go back to, say, collections. So you could take a class like this in collections, and you could subclass this entire outer class and override classes, right? Because they're always being accessed by methods. I could create a subclass of collections for primordial soup and define a class list that was different from the class list here. And everything else would continue to work, even if there were cross dependencies and I was using lists somewhere else in the module, because they're all accessing this essentially via message sends. And so if self is different, they're going to get, or the enclosing object is different, they're going to get a different list. In particular, I used to have an example of this for the parser combinator framework, where you change, there was a whole hierarchy of parsing classes, and you change the root of the hierarchy in a subclass, and everything then changed, right? The whole hierarchy now was relating to this new class. So you can do class hierarchy inheritance if you've heard of the concept or can wrap your head around it. That again is because of the late binding. It all falls out of the late binding automatically.
Great, thank you.
Okay, I think, are we back to Dave?
Oh, that would be nice. Yes, so I thought of two questions. Hopefully one is very quick. The quick one is, it looks like at any stage in the lookup, there's sort of a higher priority direction and a lower priority direction. The higher priority direction, what you sort of call the pseudo-lexical scoping. And that reminds me of Newton's script. So the question is, do I have the right model in my head?
Not exactly. It is, there is this idea of, yeah, the lexical scopers. It is, that does remind it, that is a little reminiscent of Newton's script, but it is not the Newton script model. It also isn't at every stage is the thing, right? You're going to go up your lexical scope. If you send a particular message, you're going to look at the receiver, and then you're going to look at the enclosing object, which is the instance of the enclosing class that produced the class that instantiated the receiver. And then you're going to up its enclosing object, and each one of those you're going to see if it has that selector, right?
Okay.
And
okay.
and then you're going to go. So you don't get the inherited methods of your enclosing classes by default. That's occasionally slightly annoying, but makes everything a lot simpler overall. The best thing to do about this is not the kind of thing that is, in my view, lends itself well to discussing in a talk. There is the paper, and the paper, even though it's old and it doesn't cover the access control, but other than that, it covers the lookup algorithm, and it's 7 lines. Okay, well now that's cheating because it calls helper routines. So it is a lot more than 7 lines really, but it's one section and it is well defined, and this is, in my view, it's best communicated in writing.
Okay. So the
lines of what? Just out of curiosity.
I'm sorry, should I ask the main question, or you want me to take a pass, moderator? So the main question was, this outliner I'm looking at, forgive the self-speak here. I can't figure out how many objects it's showing me because of the different headings like classes and instance methods and slots. Are those slots in various different objects, or are those all slots in the same object, or what?
Okay, so at the moment there is basically, so there is now it's probably true that we could improve the visual layout or something, but there are subsections here, right? So let's there is a list of classes. They're not expanded, so there's nothing happening inside them.
But are those just slots in the object I'm looking at?
The slots are here, right?
Okay.
These are the slots, right? There's a thing called lazy slots, which I'm implementing, but most classes don't have it, which is a different story.
Mm-hmm.
There are classes, there are instance methods, there are class methods. Each one of these are all at the same level, essentially. Now, where it gets confusing, or might get confusing, if I open this, now I have list nested. And now I have the slots of the collections class, and here I have the slots of the list class. And there is indentation, but you can argue that this, and one of the reasons you probably don't do this unless things are fairly small. Like what you typically actually do is would click on list, and then you just look at class list.
Yeah.
Now, one more complication here is that I'm experimenting with this exemplar stuff. So these are actually nested inside an object presenter. So now I'm actually inside an instance of list. So I can actually evaluate stuff here. And I have an instance of list, which is probably empty, but the idea here is that you can actually see the class in the context of the object. So if I collapse all this, right, it's just an object presenter on a list. And I happen to open the class and see all the class stuff, right? So that adds another level, and that has, arguably can get a little, maybe we should be playing with colors or something to make these outliners more clear.
You answered a question that I couldn't figure out if that was the one I was trying to ask, which when you go back to the original picture, there was this thing with a plus sign and the word classes there in the original picture.
Yeah.
Yeah, that thing. That's not a category of slots in the object I'm looking at. That is something else, but I don't know what it is.
Okay, I don't want to use the word category because it's so overloaded in Smalltalk. This is a presentation of here, instance methods, for example. It is just like instance methods in a way, right? This is a list of the instance methods you have in this class, right? This is a list of the slots you have in a class, which is actually embedded in, we can expand it and see the actual code for the header, right? And this is the list of the nested classes defined within this class. And in this case, it's empty. But if we go back to, what's its name? Okay, now it's starting to misbehave, I think.
Okay, so classes is the nested classes.
Oh, there. So here, for example, this is the top level collections thing, and these are the nested classes within it, right?
But nesting is not the same as having a slot that points to. Nesting is something different.
Nesting means that it is a property of that object or of the instances of that class. Now, how you represent that, right? Methods are also essentially a property of that, even though the code is common, but there's conceptually a property of that instance because they're tied to self, right? The classes are the same thing, right? It so happens that the implementation does cache these in hidden slots that are magical, but that's just physical storage and has nothing to do with them with a conceptual model, right? These are properties of objects of this class.
What puzzled me is I'm looking at a diagram of a class that's at a higher level than just objects and slots.
It has more different kinds of properties than just slots, right? Mm-hmm. In self, you have objects and they have sub-objects and you're done, right? We have classes and they have instance methods. Well, you also have instance methods, of course. So we have slots, we have instance methods, and we have nested classes. And, and then we have class methods, which the browser displays, because those are properties of a different, right? So these guys are a little different because this is the class side. So it's showing both the class object and the instance object in a way.
I got it now. Thank you. Thank you, Gilad.
And sorry, and the next thing can continue. So you have a collection, that's collection for primordial soup. List can have other nested classes inside.
Yes, potentially. I think we've gotten down to 4 levels. Let's see. I'm looking for something that has a lot of levels to it. Maybe this guy or one of the compiler classes probably has a lot of stuff. So so this is the top level, Newspeak to primordial soup compilation. It has a compiler class. And so one of the really nasty things that I'm grappling with is that the system slows down the more you use it. I think this has to do with the DOM or how we're using the DOM. It's not the DOM's fault. The DOM is wicked fast, but between the FFI and the DOM and things slow down. Now, okay, in any case, here's the compiler, right? We're nested in Newspeak to primordial soup, and then there are nested classes within this. And there's a rewriter and AST to bytecode compiler. Let's go inside this guy. Yeah, definitely slow down. And there's nested classes here. So now it shows me I'm in AS2 bytecode compiler, in Newspeak to primordial soup compilation, and I can go one more, I think. And now, right, code generator and AS2 to bytecode compiler in Newspeak to primordial soup compilation, right? So this is probably the most extreme example where we get to be 4 levels deep and actually useful. That's not typical, but it can happen, yes.
I'm sorry, I was unable to figure out how to raise my hand. So,
well, you're on now, so that's good.
Well, I was here all the time. I still cannot figure out how to raise my hand, so sorry to jump in. I got a few notes and maybe a question. So a few notes on this. I was always sort of thinking whether the UI for, the way we are viewing the class and the whole hierarchy, whether we could indent a little bit more, because once you start showing, deeper levels, they're just sort of one space. I realize it's not a space, but just a little bit of indentation. If we could sort of double that, that would help me. I don't know if it would help.
I'm trying to make sure I understood what you're saying. So
let's say that the greater than that you expand the hierarchy or implode or explode it, the children show indented by basically the width of the arrow.
Okay, so yeah, so there's 2 ways to look at this, right? And one way is we just follow the links. That was one of the prime reasons we couldn't use the classic Smalltalk model. And the other is, of course, if I'm in a class, I can expand it locally, and that works if it's reasonably small.
Right.
Yeah, and so it's indented as you say. Okay, this is, I guess, the arrow you meant. The width, right?
That's the indentations width I'm talking about. It would sort of help that if it was doubled.
Right. So the visuals probably need work, maybe deeper indentation, color, something, right? Basically right now, the fact is that, yeah, unless it's a very small thing, it's probably better to just go to it direct, follow the link. And right? It's also a vertical problem, right? As you expand this, you only have so much real estate, and even if you indent more, you'll hit against width problems. So there's certainly room for some tweaking of this design, but maybe because I've been using it for so long, sure, at times it can be, if this is too confusing, just follow the link, right, is the thing to do.
And that's what I'm doing. I'm just saying, for that first expand, it just,
that's sort of a good first, a good suggestion of a first adjustment to make things a little bit better. There are so many things that need doing here that I don't know when I'll get to that sort of a second order thing.
Right.
Let's see, we have Mike and Javier. So is this thing showing them in order of raising hands? I think it is. I think the higher you up vertically, the higher you are in the list. So we'll go with Mike.
Of course, we don't know that we all have the same presentation order of participants. Nonetheless, okay, so you mentioned that the lookup algorithm's a handful of lines. I noticed on your webpage, you got a whole giant list of papers that all sound interesting. I was wondering if you could point to where the lookup algorithm is directly, so that you don't have to read them all.
Yeah.
It's there.
So let's go to papers.
Yeah.
Right. So where is it? The EQ paper. I guess these are chronological, so it'll be somewhere. Actually, that objects. Why is it not showing here? Liveness, Newspeak by example, draft specification. Access control. That is odd. Let's look somewhere else.
There is one place that I know of that explains a little bit about that. That's the, it's not a paper, it's a slideshow. Can beautiful languages do access control? It's got a little bit.
So yeah, that's a presentation that goes into a lot of detail with the access control. So the original presentation, there's an eCoop 2010 paper, modules as objects in Newspeak, and if you can see my personal bracha.org website, there's a section called papers and it's linked from there. And actually, let's just open
Can
it.
you just throw that into the chat?
Yeah, I can. Well, let's see. Copy link. Where did it go? Now I lost it again. This one, yeah. Copy link address. Where's the chat? The chat is somewhere. Chat, hello.
Bottom of the screen.
Oh yeah, I have a big 42-inch monitor. The downside is I can't even find things on it. That is in the chat, and I'm gonna put up the paper right here. And it probably needs to grow. So this is the paper, and it'll be in, okay, let's make that bigger because I can want to see the whole paper. So it'll be somewhere here. I think it's around 2.4. Well, it's hard to navigate when it's so big, but semantics. Somewhere there should be the bloody slide. Okay, by the way, there are diagrams here that actually do explain the kind of diagrams that Dave was looking for. There's also diagrams in the spec that might be good. I'm just trying to find it in.
I just saw
Okay, there we go.
Yeah, okay. The link didn't come through the chat. Maybe you didn't hit send.
I did.
Huh. Oh, I'm scrolled, my bad. I also was going to ask about, I noticed that the presenter had this enclosing object thing that was often nil, but that's related somehow to nested classes. And is it like a hidden pointer the same way that the is a pointer in a Smalltalk object is like a hidden slot?
It's a hidden pointer. I don't know if I'll say it's the same as that, but okay. So I'm trying not to get into, so like beta, this nesting business has the property that it works very intuitively when you actually use it. It works like lexical scope. If it's written out there around the text, then you can get at it by its name. It's very obvious. When you actually have to actually get the mechanics of how it works exactly right, it's fairly subtle and hard to explain. That's why there's a paper. Now, the beta people originally finally wrote a paper explaining how beta worked. They had a whole, 18-page paper about beta's essentially method lookup. And the one thing I'll say is that it got simpler once we made it dynamic. Beta was more static, but it is still somewhat subtle. As I said, it is explained here, but the basic idea is this. Let's take this top-level class like collections, or collections for primordial soup in this particular case, but the collections module, if you will, this top-level class that represents an implementation of collections. You instantiate that, and then you have an object, and this object has accessor methods that will produce its own, say, list class, right? And it's important that the list class be different per instance because, for example, the list class might have been derived by sending a message what its superclass was, and that might be different in different cases because the superclass might in fact be stored in an instance variable. And so it really has to, you have to have a class per instance. Now, okay, now you've got class list. So now if class list wants to access properties of the surrounding class, then it needs to have a hidden pointer, if you will, to that object of the surrounding class, right? If I have an instance of list, it's its own instance, but it is accessing things in its, quote, lexical scope. And that means that it has to have some reference to an instance of the collections class, right? And that's the enclosing object, right? Does that make sense so far?
Kind of. Is enclosing an object just something that classes have, or do all objects have an enclosing object? Do ordinary,
Okay, all objects have an enclosing object because they all have methods that can reference the enclosing scope, right? Now, how you represent it may vary. You may use the class as an indirect, there's various ways. You may begin to get the sense of why I did not want to explain it in a talk, because it needs diagrams and text and whatever. Let's see, we had that image here.
It sort of feels like a lot of work to go through to preserve the Smalltalk class style model, but have the other properties you want. And I'm wondering if there isn't some other model that would let you have the properties and it would just be different from what class-based thinkers are used to.
Okay, I'm going to say this again. Like in beta, the fact that it is a little tricky to implement doesn't have any bearing on the fact that it is extremely easy and natural to use. So no, I don't buy that at all. It is a bit of work. I could say something like having a clever virtual machine that dynamically monitors how often a method is called and decide how to optimize seems a lot of work just so you could use objects. But I'm not going to say that or pretend I didn't say that, right? Sure, it's a little bit tricky to implement. There's nothing actually problematic. You don't need to know any of this stuff to use this. Basically, do you understand lexical scope? Thank you, you're done.
Well, just as with the virtual machine, the drawbacks come when you have bugs or errors you can't figure out, which we certainly had plenty in building the virtual machine. And I'll just take your word for it that you'd never have those in
okay, first of all, a virtual machine is a lot more complicated than this particular lookup algorithm. And yeah, that's why you need people like Craig in order to implement it.
And me,
actually
some of the key
have
ideas were
problems with the
mine.
lookup algorithm because it is only a few lines. And yeah, Elliot got it wrong the first time, but that's not surprising. You got it right the second time. That is pretty good. And it is not very complicated. I'm sorry. It is subtle to explain and subtle to implement, but not. It's a very small thing. It's again 10 lines, and really, you know.
Why is it hard to explain if it's not complicated? Are you missing some terminology or notation, or what's that about?
Because there's a lot of power that unfolds from a few steps that if you get them wrong, they'll do something else, right? It is a matter of precision.
And that's hard to explain where the important steps are.
Basically, you can tell where the steps are, but mainly you have to understand why those steps are and for what purpose. So, you know, I'm going to say it works just like beta. It's very, very simple to use, and it is a little tricky to actually go through the model. People who want to, we can do that, and then you'll actually say, yeah, it is complicated to understand the model at that level of implementation.
No, I'm just trying to understand what this reveals about the class-based model. And I think there's something there, but I should let other people talk again. And
yeah.
For the record, I thought your comment about Urs and Craig was a bit of a diss because it was original ideas I had, like maps and customization, that made it possible to do all of that stuff, along with ideas that a lot of other people had, and a lot of brilliant work by my then graduate students.
I certainly didn't mean it that way, but it is getting it to work well and implement it is very hard. And you were fortunate to have some incredibly clever grad students, right?
Yeah, I did a ton of debugging after they left too, but that's another story.
That
And I
is
was
the nature of
fortunate.
students, yeah.
And what you need is a ton of grad students to prove this. But go ahead, Gilad.
Anyway, I did not mean to diss anyone, neither you nor Urs nor Craig nor anybody. They're all of the above are a lot cleverer than I am. But I am saying that this is actually one very small piece that is tricky, and you get it right, and the model the user gets is very, very intuitive and simple, actually, if you use it.
The trickiness sounds a little like the history of choosing the right environment for a lambda in Lisp. I mean, there's lots of different choices that were made over history before, say, schemes settled on lexical scoping. Even though it's small and simple, it is.
That's a good analogy. It certainly is. It is like that. So yeah, there are hierarchy. The fundamental thing here is that hierarchy is important, and hierarchy is a basic construct that you need. Now, if you do it just with objects, as Dave says, it is simpler because you don't have this extra level of instantiation. But yeah, on the other hand, classes have advantages, and we could argue that till the
I'm not sure it is simpler just with objects. I think there's something deep lurking that I don't understand about the attraction of the things that led to the invention of some of the stranger things in self. And there's something going on here having to do with the discrepancy between how simple it is for you to use it, if I understand you correctly, and how tricky it is to explain it and make the right decisions. And I can't put my finger on it. And where that stuff typically surfaces is when, like in self, when we would have what looked like bugs in programs, but it turned out that we had gotten too clever with the multiple inheritance disambiguation rules. And one place it might surface here is if my program doesn't do what I expect it to, because my mental model programming doesn't jibe with exactly what's implemented. But on the other hand, I take your word for it that doesn't happen. And that makes the puzzle more intriguing still.
Yeah, I see what you're saying. The thing is, you can create test cases. I mean, there are test cases with a compiler where you need to stare and say, oh, what is this going to do? But I've never had any real code like that. It just, because usually it's a lot, it's basically a hierarchy, right? Is what we're trying to support here, because that is very important. And yeah, what can I say? I believe it works. You don't have to take my word for it. You can, you know, but there is a subtlety to it, right? And this this diagram sort of shows part of what's going on. But another example this reminded me of is like the Smalltalk metaclass hierarchy. That's another thing that you know, is non-trivial, right? And
it may be that when you write the type checker for this language, some lights will go on and it'll answer some of these questions I've had.
Maybe. I'm not sure I see that, but then again, maybe when I write it, I will. Right, so even though I have the diagram here, I don't have a particular appetite for going through it unless someone insists. But I think Javier had a question. You're not marked as muted, but I can't hear you.
Can you hear me now?
Yeah, now you're good. Okay.
So nice to see you again and to see Newspeak advancing. So I had a couple of silly questions. The way I try to understand new stuff is by comparing it to the stuff I already think I know. So I was having a look at some code in the browser of Newspeak, and I was wondering how you do some stuff that I know how to do in Smalltalk, right? So one of the differences is that you don't have all the meta classes, right? So I wonder where the functionality you get from meta classes is stored. For example, if I wanted to copy an object, right? In Smalltalk, I can say to an object copy, and I get a new instance with the same instance variables, right? So I wonder, how do you do the same in Newspeak if you can? And also, I was having a look and I didn't find object. So is there an object class?
There is an object class. You'd have to look in kernel.
Could you show us?
And there's a weird bootstrapping thing going on there. So I'll answer those questions in reverse order, I think, because the second one is easier. Object is object along with a handful of other things. Array, byte array, integer, string, maybe I'm forgetting something, float, I guess. These are methods in object that everyone inherits. So you could say, oh, there is a global scope in the sense, not a global lexical scope, but there is something that everybody has because the things that are in object. Now, object doesn't have a whole lot of stuff in it, and if you look for object, then you'll find it in the kernel class, kernel for primordial soup. Let me see. So it'll be kernel. This guy. I think it says there. Yes. So see this guy underbar object. So this is some messy bootstrap thing. Why? So the accessor for object. Let's look at object. There. Right. So there is a protected method object. And what it does is it gets the underbar object from the enclosing scope. And it's very deliberate about doing this. I'm not quite sure why. Why doesn't it just do underbar object? That would have worked fine too. But yeah, I'm not sure about that. But basically, it has to, why it's called underbar object has to do with some bootstrapping thing, right? Where it gets a little tricky to just create the absolute core of the system. But other than that, object has, you know, equals and identical and hash, and you can see it doesn't have much, right?
So every class from the system inherits from this underscore object.
Yeah. Now the fact that it's called underscore object is nobody's business, right? Unless you start reflecting, right? It's really, you know, you get it by calling object, right? Because you're never going to access the class directly. You access you get the method. The method is called object, and that's actually what you care about, right? Now the thing is, as you can see, it doesn't have a whole lot, right? So this is different from most small talks where there is just an enormous amount of functionality in object. And this is kind of a philosophy thing that it's just too much stuff, and some of this stuff, you know, again, if you look from the security, you don't necessarily want everybody to be able to copy objects, right? We don't want that, right? So if you need to copy object, if you need your objects to be copied, you'd make your own copy method. If you need to copy objects in general, then you use reflection. You know, and maybe there isn't necessarily all the utilities that you want in the system, because It just isn't as comprehensive and thoroughly built out.
Is reflection safe from the point of view of security?
Reflection. Okay, so is shooting yourself safe? No, it isn't safe from a point of view of security, but it fits with the model. So reflection is mirror based. So hello. Where's the mirrors? Mirrors for primordial soup. So the idea of mirrors is that you have made reflection into a capability. You can, so in Smalltalk, right, you can go and say, class, and then you can get at everything and change it and do everything is directly. That model is very intuitive. It's very direct. It's properties of the object, but it means that everybody can do everything, right? Whereas, what happened here? Okay, I'm gonna just, hello. Yeah, let's restart this because I'm suspicious that this is misbehaving. Yeah, so this is the mirror class, and it has a bunch of different mirrors, nested classes in it for things like stat frames, activations, for example, or methods, or classes, and mix-ins, and slots, and threads, and so forth, right? And so if you pass someone, so if you write a module like to do MVC, it doesn't import mirrors, and so it can't use any of this stuff. If you do import this stuff, you can do pretty much anything. Now all bets are off because it can modify stuff and so forth. If you wanted someone to say, you didn't trust someone to do this, you could give them an attenuated version of mirrors. That is, you could wrap an instance of the mirror package in another object that only gave it access to certain things or checked things, and so forth for the subclasses. So an object mirror has a possibility to do perform, to set slots. You could wrap it in something that says you can't set slots or you can't get the class. So you can attenuate things because they're objects and they're object capabilities. So the fact that you have factored into a separate layer that means that you can get at regular objects for regular execution without having any access to reflection is important. And the fact that they are then individual objects with the methods that you can control what they do or wrap and emulate the protocol means that you can give someone, say, an object mirror that only will let them reflect their objects, right, of their class or something. Now all of this is hand waving because I haven't done any of that work, right? There is this there are the mirrors, and you can do whatever you want with them, but they are fundamentally such that you can control security. And of course, I should note where mirrors come from. If anyone has any doubts, there's a gentleman with a blue shirt who can explain to you where they came from, which is Dave, right? They come from self, and they're, they solve this problem of, in a way, among the many things they solve is security versus reflection, in principle.
Thanks, Gilad. And you did a great job of explaining the principles behind them in the paper that you started, that we wrote together.
Oh yeah, Dave and I wrote a paper once upon a time in 2004. It's still out there, and it does say pretty much all you need to know about mirrors, I dare say.
Won a lasting impact award.
It did? Oh,
I'm pretty sure.
Okay, well, good. I may have forgotten or not realized or wasn't there when they handed it out. So I appreciate whoever realized that it was a good paper and had impact. I appreciate that, but I think I didn't realize that. Anyway, I hope that answered your question.
Yeah, sure.
Okay, who's next? Now I think, is it Francisco or Milan? I don't really know. It's not you. Okay, your hand is slightly less yellow, so that must mean that it's not active. Yeah, Milan, go ahead.
All right, so we've got one question and one note. So the question, the lazy slots you are working on, I'm assuming the primary purpose is to have a slot that can be initialized later, but it's not necessarily a setter. It's immutable, but it can be initialized later, right?
Okay, so I'll explain what lazy slots are for. That's Newspeak was originally intended for this project for what I called orthogonal synchronization. And the idea there was basically that you could write apps where the platform would take care of syncing in the way that, say, Google Docs syncs across multiple copies on multiple machines, right? So that synchronization would be basically a built-in service of the platform. That's actually what we were after, and what the story we told to the people who actually at Cadence who actually paid for the development of Newspeak originally. Now we never got there because we built a language and an idea, all this stuff along the way, and then they came. The crash of 2008 came and it all died. But the idea there was that originally there was supposed to be a notion of transient slots. Transient slots were supposed to be slots that were not persisted and synchronized, as opposed to the ones that were. And over time, I decided that, okay, let me back up because I do want to try and make this clear. Lazy slots are basically the idea that you have a slot that will be initialized when it's first called, when the accessor is first invoked. That's a pattern that I find is fairly frequent, that you have something where, okay, it's actually going to be, it's nil initially, and when you access it, I want to then compute it and set it, and after that, I'll use that cached value, because for various reasons, I didn't want to initialize it up front.
And it's immutable after, right? So once it's first set, because
after it's set, that value is there and it's cached and you can get at it. The idea for transient slots was that they would behave this way, and then when you synchronized, you'd nil them all out, and then they'd be recomputed based on the persistent data that you had synchronized. And so they'd always give you the up-to-date value. And so they shared this property of being lazy and being computed this way. And I've seen that it's a fairly useful pattern, but their real intention is that someday I hope to still get to the orthogonal synchronization. But they're generally useful, right? There's a fair amount of cases I find where there's this kind of thing that I declare a slot and then I have an accessor method for it, and I'm forced to declare an accessor method again because now I want to actually have this computation where I lazily compute it and check if it's nil or not and all that stuff. And it's convenient to have something that just supports that directly, especially for this idea of orthogonal synchronization, which is a whole separate talk. In fact, I wrote a blog post about this just the other day. And so, that's why the lazy slots are coming. Did that answer the question?
Yeah, I think so. I think so. Yeah, thanks. The note that I have is that, as you know, I guess, I mean, following Newspeak for, in fact, very long time, but with very, very low intensity until, maybe at some point last year where I started, trying to learn it more, use it more. And so one of the things that I think came up today is that, how does the, method lookup sort of, how does it fit in within, inheritance versus, the encoding scope and stuff. And I was struggling with that as well. But once at some point, I think in the list you explained, just think about it as a lexical scope first. And so I started thinking about it that way. And although all my examples are very, simple, primitive, that works. That sort of, if I don't have to understand the details, I guess, but this is sort of intuitive. Think about it that way, and that works for me. I've also, I guess, a third note. It's not a plug in any way. As you know, I've sort of documented my squeak learning in a blog post. I can share that if there is any interest. At the same time, it may be more confusing to people compared to reading the original stuff.
Yeah, go ahead and put it in the chat. Right. So Milan did write a blog post about his experiences using Newspeak and what he encountered, and perhaps that's useful to people, because obviously to me this is too obvious and I may not be doing a good job of explaining some of this. Tudor. Hey.
Thanks a lot for the presentation. This is lovely. I still have a question about, is it possible to inject methods? So basically the corresponding of method extensions in Smalltalk.
So I admit that I never liked that. And so I'm getting an echo from somewhere. I'm not sure why. Let's see. Yeah, it is you, Tudor. I don't know why. But so method extensions, the way to deal with those things, I believe, is through class hierarchy inheritance. That is, you think of your whole package as a top level class with whatever functionality it has, and you want to add new stuff, then you can create a subclass and you can only add the stuff you wanted to add, right? And it'll all work because of the self-reference that ties it all together. And in fact, if you want to understand how that works, and you haven't heard enough of Newspeak, there is on YouTube the talk that I gave at the California Smalltalk meetup 6 months ago or so, where, because I took a different tack on presenting this, I spent a lot of time on the expression problem, for those people who know what that is, which is a classic topic in programming languages and sort of O versus functional and things like that. And so I showed class hierarchy inheritance extensively there, and you could use it for that kind of thing.
And then related to that, so first, here is what is not clear to me, and I don't picture it. I can picture one extension or just one-time extension. I'm not sure if it would work with, if I have an arbitrary amount of extensions, like arbitrary places of code which would like to inject, because basically there you would need to create an arbitrary amount of subclasses.
You need to use them as mixins.
Yeah, so maybe, exactly. So maybe I'm just not picturing it now.
They're basically mixins, and you would have to compose all the ones you wanted explicitly to say, apply this one, apply that one, or whatever. And as long as they don't conflict, otherwise you will, the order will resolve that, but maybe not necessarily the way you expected, right? But yeah, I think that other presentation might be useful in that regard, even though that's not the emphasis, but it does show the whole mechanism, how you actually extend a nested class, the whole class hierarchy thing. It's a big part of that presentation.
So Tudor, I think you have a wrong model in your head. So you say think of all kinds of parties adding something to a class from somewhere, but actually it's more like an onion model. You add your own shell around some class, and somebody else can do that as well, but it don't interfere with you at all. You just use the same base. You just add your private stuff on top of it. I think it's very clean.
I was going to say that's the shell theory from Christian.
Yeah.
Okay. So the difference, of course, I'm not sure quite what Christian, am I right? So there's always this thing that you can wrap things, but here you're not wrapping them. You're defining individual mixins, each of which is that particular extension.
Yeah.
And then you apply those mixins to whatever the base was, and you get the completed thing, right?
Yeah. And so then related to this, is it also, I think you would use the same mechanism to add state basically to an object arbitrarily from the outside. So adding a new slot dynamically.
Well, depending how dynamic you mean, but you could basically, you can extend the code in whatever way, right? You could add new methods, you could add new slots, and you'd be basically this new version would have classes overridden in such a way that these instances would have new slots, and you could do that. It's maybe not as dynamic as, you know, I'm not sure what use you have in mind for it, whether it's quite the right answer for that. Right? You certainly can do that, but I'm not convinced that it will necessarily always be what you sort of wanted. Kind of probably a long discussion.
For example, in a you know, whenever you have a GUI framework, you might always want to inject some extra state, and it's great to be able to preserve self.
Yeah. So okay. So a class expression problem is actually a classic example. The example. So ASTs, right? You want to you want to attack stuff onto ASTs. I've done. Yes, it works for that. I did that. I don't think that's public anywhere. Maybe it is. So as an experiment in the ShapeRank project, which is this other APL-ish language that I've been playing with, I decided to implement, there's a Newspeak interpreter for it, and it is implemented with an AST where you use that pattern. So there's a pure AST with just AST stuff, and rather than having visitors, there are subclasses that add properties to the AST. Yeah.
Cool. Yeah, very cool. And so now a third question related to that one, next one would be, is it also, like, in my mind, it kind of would make sense to, or would be possible to also end up with instance specific slots by just changing the class? What is it? How would that work?
Not really. This is where you really want something like self, I suppose.
Yes.
So I mean, I'm sure you can twist, just like, you know, you can make it do things, right? You could create classes that that sort of somehow made sure you only created an instance. And so, but it's very convoluted, I think. I don't think doesn't strike me as something that would work well.
Okay, thanks.
Thank you.